I'll go over the assignment 1 answers quickly in this video. So, question 1. Given the sets S1, S2, S3, S4, which of the following statements are true? So first, S1 equals to S3. This is true because S1 is 2, 4, 6, and S3 is 4, 2, 6. So they have the same kind of elements in them. I said that the orders doesn't matter, whether or not it's 2, 4, 6 or 4, 2, 6. As long as the numbers, the elements are the same, they are considered to be the same set. So S1 equals to S3, that's true. And B, some people get wrong in the B here. S1 equals to R, the set of real numbers. The answer should be false. Right? We know that S1 has 3 elements, 2, 4, and 6, and all the 3 numbers belong to the real numbers. Right? But we cannot write S1 equals to R in this way. We should write S1 is in R, or S1 is a subset of the real numbers. We cannot write the equal sign because S1 only has 3 numbers, but the set of real numbers are infinite. Right? All the other numbers, whether or not it's an integer or fraction, all of them are called real numbers, right? Not only the 3 of them. So S1 should be a subset of R, so they're not equal to each other, right? If you draw a graph, so this should be S1, and in the square, the rectangular should be all the set of real numbers. So B is false. And C is wrong because there's no number 8 in S2. Right? And D is also wrong because there's no number 3 in the set S2. And E is right. E is wrong. Oh, sorry. D is right, because this sign means 3 is not in S2. So this is right. Let me check that. This is right. And E is wrong because 4 is a element of S3. So this should be this sign, right? Is in S3. So this should be this sign. So F is also right because S4 is a subset of the real numbers. And G is also right because S4 has 2 elements, 2 and 4. S1 has 3 elements, 2, 4, and 6. And 2, 4 is part of the 2, 4, 6. So S4 is a subset of S1. And H is also right because this is an empty set. An empty set is a subset of all the sets. Right? Empty set is a subset of all kinds of sets. So H is right. And also the empty set is a subset of S1 or S2, S3, or S4, right? All kinds of sets have a subset called empty set. And I is wrong, it's false, because there's no the number 1 in the set S3. Okay. So that's question 1. And question 2, again, we have the 4 sets. And let's find A to E. So first is S1 union S2. The union means we take all the elements in both sides and add them together. Right. So S1 union S2 should be in S1 there's 2, 4, and 6. In S2 we have 7, 2, 6. We take all the elements together. So all the elements here are 2, 4, 6, and 7. So this should be the answer. And S1 union S3 is the same. S1 has 2, 4, 6. S3 union. S3 has 4, 2, 6. They have the same elements here. So union means, again, 2, 4, 6. Right? All the elements are 3 elements here. And S2 intersects S3. S2 is 7, 2, 6. S3 is 4, 2, 6. Right? So intersection means we take the common elements in both sides. So what are the common elements? 7 is not common element because it's only in S2 but not in S3. So the 2 common elements or shared elements are 2 and 6. And S2 intersects S4. S2 again, it's 7, 2, 6. And S4 is 2, 4. So the only common element is 2, right? 2 is in both sets. And E, S4, that's 2, 4, intersects S2, 7, 2, 6, intersects S1, 2, 4, 6. That means that we need to find the common element in the 3 sets, right? The only common element in the 3 sets is number 2 in all of them. So the answer should be the set 2, right? The set with the element 2. And the last one, we need to find the union of the 3. 4, 2, 6, union. S1 is 2, 4, 6. And the S4 is 2 and 4, right? We need to find the union. That means we count all the elements together. So that's 4, 2, 4, and 6, right? So here are all the elements that appear in the 3 sets. So that should be the answer. And question 3, which of the following are valid? So number 1, A is any kind of set, right? Just a general notation. So A is any kind of set, whether it's empty or not empty. It doesn't matter. It's a set A, right? A union A equals to A, right? This is valid because, as I said, union means we take all the elements in both sides, and even if it appeared in only one set, it doesn't matter. We just count all the elements that appeared in both sides, and then we gather them together, and this is our new set. We call the union set, right? And all the elements in A, of course, is the same element as in the set A, because it just himself, right? The union A is a set A is the same as the set A, right? So when you union the A with the set A itself, the elements are the same. So the union result should also be the element A, the set A. Right. And also the same thing, A intersects A is still equal to A because the elements are the same, right? Intersection means we need to find the common elements in both sides, in both sets, right? And this is our intersection set. And for the set A, because all the elements are the same, so even if we take the intersection, the remaining set is still set A. So A and B are valid. And C, A union an empty set is still the set A. This is also true, right? Because, for example, if A is 1, 2, and it unions empty set, that means that we take all the elements that appear in either set, and then we combine them together to a new set, right? This is the definition of union. So what kind of elements appear in the set? For the first set, we have 1 and 2, right? For the second set, it's empty. So there's no element in this set. So we only have 1 and 2 in our union set. And we can see that after taking the union set, the result set, is still the same as set A. Right? So any set union an empty set is the set itself. Right? Doesn't change. And D, A union a universal set is also the universal set. This is also true because, as I said, the universal set includes everything under consideration. So if this is the union set, this is a universal set, and this should be the set A, right? Universal set is the large rectangular, and A is a small round circle in between. So a smaller set union a larger set should also become the larger set itself, right? Nothing changes. So D is also valid. And for E, any set that intersects with empty set should be the empty set. Again, this example 1, 2 intersects the empty set. As I said, the intersection means we take the common element that appear in both sets, and that is our intersection result. But here we have the empty set. That means that there's no element in this set. So the common element in both sides should be empty, right? Because there's no element here, so there's no element in the intersection, right? And F is still valid. A intersects the universal set is the A itself. Again, this graph, A is a smaller part that's contained in the bigger set U, right? A is a subset of U. So A intersects U is just the A itself, because U has all the elements that A has, and has a lot of elements that A doesn't have, right? So if you take the intersection, the result will only have the elements that A have. So the smaller set intersects with a larger set, which is this is a subset of the U, but the result should also be the set itself, A. And G is also valid. The complement of A tilde is A. As we said, the tilde sign means we take the complement of the A here. So A tilde is a complement set of A, right? So the rectangular is the universal set. And if this is A, then the other part is A tilde. Other part means outside of the set A, but still within the universal set. This part, the shaded area, is A tilde. So if we take the complement of the complement of A, right? So A tilde is the complement of A. And we take the complement of the complement set, then that means that we need to find out the complement set of the A tilde set, which is just A, right? Because A and A tilde are both complement sets of each other. So the complement set of A is A tilde, and the complement set of A tilde is A. So that's the relation between them. Okay. And question 4, does any of the following represent a function? Okay, let's draw the coordinate plane. This. So A is a circle. Of course, it is not a function because the definition of function means for a given x, there's only one y value that is corresponding to the value x. Right? For a given x, there should be only one value that is associated with that. Okay. So in this example, if this is a circle, then there are 2 points here that have the same x, but we have 2 y values here, y1 and y2, right? In this case, it's not a function. And for triangle, it's the same, right? For a given x, there will be 2 y values here that have the same x. And for rectangle, it's the same, right? But for a downward sloping straight line like this, it is called a function because for a given x, there's only one corresponding y, right, in the graph. There's only one corresponding y. You cannot find 2 y's or 2 points on the line, on the shape that has the same x. So only D represents a function. Question 5, if the domain of the function is the set 1 to 9, find the range of the function. Okay. So that was our last topic in chapter 2. So domain, it simply means the set of all the potential values that x can take. Right, so here x is from 1 to 9. Right, that means that for this function, x can be chosen from 1 to 9. It can be 1, it can be 1.1, 1.2, 1.3, or any kind of number that lies in between 1 and 9. Right? So this is called the domain of the function. And the range of the function is that given the domain of the function, what kind of values the y can choose. Right? So here in the example, we've already know that the x can be chosen from 1 to 9. So given this condition, what kind of values the y can take? Right, y and x has this relation, and x is from 1 to 9. So what about y? Right. So this is called the range of the function. And how to find out the range? Okay, so here in this example, if we draw a line of y equals to 5 plus 3x, it should be something like this, right? It's a linear function. It's a linear line or straight line, upward sloping straight line on the coordinate plane, right? If you draw the function on the plane like this. So it's a straight line that's upward sloping, which means that when x reaches the smallest value or the minimum value, y is also in the minimum value. And if x reaches the maximum value, the y is also in its maximum value, right? Because they are positively related. When x increases, y also increases. because there's an upward sloping line, and when x increases, y also increases, like the relationship does. So when x equals to 1, y has the minimum, right? When x equals to 9, y has the maximum. We don't need to care about the y values that is between 1 and 9, right, of the domain, because when we find out the minimum and the maximum values of y, then we can make sure that y, the range of the function, will lie in between y minimum and y maximum, right? So here we first need to plug in x equals to 1 in the function and find that the minimum value of y is 8. And the maximum value of y is simply to plug in x equals to 9 into this equation and find that it's 32. So we know that, okay, the range of the function, or the potential values that y can choose under the domain, should be from 8 to 32, right? And pay attention that this is a smaller or equal sign, right? There's an equal sign here, not just a smaller than. So that's question 5. Question 6. In the theory of the firm, economists consider the total cost C to be a function of the output level. So C is a function of Q, right? And A, according to the definition of a function, should each cost figure, that means that should each C be associated with a unique Q, right? Q is a level of output, right? So should each C, so C is the y, or the dependent variable in a function, and Q is the x, or the independent function, right? Because when we write the function like this, so this is called the dependent variable, and f of Q, that Q is called independent variable. So C is a function of Q, right? When Q changes, C also changes, right? Okay, so C is y and Q is the x. So this question just means that should each y be associated with a unique x? And the answer is no, it doesn't have to. Why? Because, as I said, there's an example in our chapter notes when I talk about that in the video, that this is a quadratic function, right? This is y, this is x. For each y, there are 1 or 2 x values that is associated with the y. So this x1, x2. But it's still a quadratic function. It's still a function, right? Because by the definition, according to the definition of a function, right? According to the definition of a function, we only require that each x has a unique y, where x uniquely determines y. But we don't require that y uniquely determines x, right? So it doesn't have to be the unique x that's associated with the unique y. As long as for a given x, there's only y that's associated with it, it is called a function, right? We don't have to require that for each y, there's only a unique x that's related, right? We don't require this. So for question A, it doesn't have to, so the answer should be no. Okay. And question B, should each level of output, that's Q, determine a unique C, right? As I said, Q is a x, C is a y. So this question means, should each x determine a unique y? And the answer is yes, because this is a definition of a function, right? Each dependent variable, or sorry, each independent variable should determine a unique independent, sorry. Each independent variable should determine a unique dependent variable. So each x should determine a unique y, right? So A is no and B is yes.